Welcome to Module 4, the BAS Professional Competency Model. A professional career is defined not only by what a person knows, but by the quality of the decisions that person can make, explain, implement, and teach. In this module, we will look at the 5 components of competence, the 10 BAS competency domains, the T-shaped professional, career progression, the expert trap, and how to build a real development plan. By the end of this module, learners should be able to distinguish the 5 components of competence, identify the 10 BAS competency domains, explain the T-shaped professional model, understand career progression, and recognize the risk of depending on one expert. The goal is practical. Build a development plan that improves safety, reliability, team capability, and leadership readiness. Building automation crosses disciplines that are often separated in other industries. A BAS professional may troubleshoot a sensor, review an IP network, analyze a hydronic sequence, and explain capital risk to management in the same day. Technical knowledge matters, but it is not enough. Mature performance requires applying knowledge, evaluating risk, communicating with different stakeholders, and working through controlled processes. The book organizes competence into 5 components. Knowledge answers, what do I understand? Practical skill answers, what can I perform correctly? Professional judgment asks, what should I do, in what order, and with what level of risk? Communication asks whether I can make the situation understandable to the people who must decide or act. Professional behavior asks whether others can rely on how I work. A weakness in any one of these areas can limit the whole professional result. The 10 domains are building science and HVAC, electrical systems and instrumentation, controls engineering, communications and networking, servers, software and data, OT, cybersecurity and resilience, operations and reliability, project delivery and commissioning, leadership and workforce development, and business strategy. The objective is not equal mastery of all 10. The objective is enough breadth to recognize dependencies and enough depth to contribute expert value. Another way to understand the competency model is to group it into foundations. Physical foundation includes building science, HVAC, electrical systems, and instrumentation. Digital foundation includes controls, networking, servers, software, data, and integration. Operational foundation includes reliability, maintenance, cybersecurity, commissioning, documentation, alarms, recovery, and lifecycle support. Leadership foundation includes governance, mentoring, vendor management, business strategy, metrics, and executive communication. The T-shaped professional model is one of the most practical ideas in the chapter. The horizontal part of the T represents broad cross-disciplinary understanding. The vertical part represents deep specialist expertise. Depth creates credibility, but breadth protects the whole system. A specialist with no broader awareness may optimize one component while harming the building. A generalist with no depth may understand the conversation but lack technical credibility. The goal is balance. Career progression in BAS usually expands from safe execution to diagnosis, design, program leadership, and strategic direction. A technician asks, can I complete the assigned work correctly? A specialist asks, can I explain why the system behaves this way? A lead asks, can I design a solution others can build, operate, and maintain? A BS manager asks, can I build a reliable program rather than solve isolated problems? A strategic leader asks, can I align building technology with organizational mission and capital strategy? The expert trap is a serious management risk. A highly capable person can become an organizational single point of failure when difficult work always goes to the same person. Troubleshooting is not documented. Credentials or backups are personally controlled, and others are not given learning opportunities. The expert appears indispensable, but the organization becomes fragile. The manager's goal is not to remain the only person capable of solving difficult problems. The goal is to multiply expertise. The book gives a field experience where a facility relied on one senior specialist for major BS incidents. He knew undocumented network settings, held local copies of backups, and resolved problems quickly. The arrangement appeared successful until he was unavailable during a critical communications failure. The larger correction required centralized documentation, controlled credential storage, cross-training, backup testing, peer review, and scheduled recovery exercises. Capability is what remains when the expert is unavailable. A development plan begins with a current capability assessment. It defines role requirements, prioritizes gaps, chooses development methods, requires demonstrated capability, and reviews progress. The methods should be mixed: formal education, vendor-neutral technical training, manufacturer training, field assignments, mentoring, commissioning participation, incident investigation, design review, professional reading, and teaching others. Courses build knowledge, experience builds judgment, teaching reveals whether understanding is complete. A vague goal like Learn BACnet does not prove capability. A stronger outcome says create a documented BACnet architecture, diagnose a duplicate device instance, explain broadcast behavior, and mentor another technician through a communications issue. That is observable. It can be reviewed. It produces evidence. The BAS manager should define development in terms of demonstrated capability, not only completed courses or certificates. Common competency failures include software knowledge without mechanical understanding, mechanical knowledge without networking or data understanding, technical depth without communication, management authority without technical credibility, innovation without operational discipline, training that teaches menus but not reasoning, certification without field application, and teams with no backup support for critical systems. The principle is clear. Your value is measured not only by the problems you solve, but by the capability you create around you. The Team Capability Checklist is a practical assessment tool. It asks whether mechanical knowledge is available, controls programming is not limited to one person, network and server responsibilities are defined, cybersecurity coordination is documented, critical systems have trained backup support, administrative access is centrally controlled, development plans exist, knowledge transfer is scheduled, project work includes training and documentation, and succession risk is reviewed. The checklist should reduce risk and create opportunity, not embarrass people. The practical exercise for this module is to create a competency matrix with team members in rows and the 10 competency domains in columns. Rate each capability using evidence. Then identify systems supported by only one qualified person, immediate cross-training priorities, one field assignment for each development need, evidence that will demonstrate improvement, and a 6-month review date. The purpose is to identify risk and development opportunities, not to publicly rank employees. This module introduced the BS Professional Competency Model. The key message is that professional effectiveness includes knowledge, practical skill, judgment, communication, and behavior. The 10 competency domains help identify strengths and gaps. The T-shaped model reminds us that breadth protects the whole system, while depth creates credibility. The expert trap reminds managers to build capability, not dependency. In the next module, we will build on this by studying systems thinking and root cause reasoning.